my name is Ryan Harding, and today we're going to be going over the radius, diameter, circumference, and pi. So now you're probably asking yourselves, what is all that? Well, I'll go into the basic definitions and how they are expressed and how they can be used in just general sense of how to solve each circle. So what is the radius? The radius is basically the distance from the center point of the circle. So let's call this the outer edge of the circle. So this is radius. This radius would be expressed as r. Now, radius is solved for area and circumference and other forms of solving a circle. I don't know all those. I primarily know area and circumference. But now, next thing we need to know is what is the diameter? In another color here, let's say red. So the radius, or the diameter of the circle, I'm sorry, is total distance from one edge of the circle to the other through the widest point. So draw it out here. So this is diameter. That is the diameter of. So now we know that basically diameter is double the size of the radius. And so we can also write it out as r. So knowing that, now we can use that to find the circumference. So let's say that the radius of the circle is 3. Let's say that the radius is 3. Oh, I should have wrote that in green, but it doesn't matter. Let's just say it's 3. Now, we want to find the circumference. And what we need to know is that the circumference of the circle, entire outer edge, say the entire, that the entire outer edge of the circle, that sounds terrible. Circumference is the entire outer edge of the circle. Sorry about that. I just trying to get rushing through that a little bit, but entire outer edge of the circle. So to find the circumference, we need to know what the equation is. Let's just actually, the equation we need to know is pi r. Now, if the equation gives you the diameter of the circle and you still want to find circumference, it can also be written as pi this. Okay. Yeah. There we go. There we go. So now, knowing that, we can use radius over the diameter to solve for circumference. So let's say that the radius was 3. So r, and we need to know that the equation is 2 pi r circumference. So now all we have to do is plug that in, and let's say that pi equals 4. Pi circumference. Now we know we can simplify this down, just do times 3, which equals 6 pi. See. Now, some people like to leave this in what is called in terms of pi, which is basically where 6 pi is equal to circumference. But if you have a calculator, you can punch that in and it'll give you a much more specific number. Now, some of you are going to be asking, what is pi? Pi is basically the ratio of circle. It's basically determine, of course, with the radius, circumference, the diameter. It's used to determine all that sort of thing. So there's a ratio between circumference and diameter. So let's say that the ratio is should equal pi. And no, it is not spelled like pie, as in the food. It is spelled like I. This is a Latin term. I don't know what it means in English, but so circumference over diameter will always equal pi. That is the ratio. So now that we know that 6 pi equals c, now we just say that pi is 0.14. Let me grab the calculator. I can't do that. I don't know too much I could do. So let's 6 it equals 18 at point back to you. A C. So that's a good thing to know. Now we know that the outer layer of this circle meters. So let's just give it a unit. Now, of course, pi is an infinite, repeating decimal. So no one knows what the total, what the entire decimal is. So, but most people just like to classify it as 3.1. So pi equals, say, 4. Of course, it can be on, and as you get into complicated math, the problem could say, and pi to the, say, thousandth, to the thousandth. So just 1, 4, tenths, hundredths, thousandths. That'll be 3.141. Not too difficult, but 3.141, 5, 9, 6, 8, I'm pretty sure is how the order. I could be wrong on the last two. But again, it just keeps going on and on and on and on. End. So I guess most people in Algebra 1, Geometry, and Algebra 2 will typically say 3.14 for pi, or just say leave it pi, which in order to that, this would be the answer if you pi. So that's all you need to know about radius, diameter, circumference, pi. Now, of course, I did say that that circumference over the diameter is always going to be pi. So that is just basically the significance of radius, diameter, pi, and how they all come together to make one thing. Now, even though that this lesson generally doesn't go for area, I'm going to show you how you can apply radius and diameter to area. This is just an additional thing. I know it's not necessary, but I'm going to include. So say that the area is going to be pi r squared. R squared. And let's just keep the same numbers here. Let's just say pi squared. We can differentiate it. So now we get 9 pi is equal to area. Of course, you just get a calculator, you punch that in, and boom, you have the area. Let's just say it'll be somewhere around 27. I can't give an exact number. It'll be between 27 and 28. So that is how the area can be. Now, of course, we said that r equals 3. If it gives you the diameter, which in this case, the diameter would be 6 because it's diameter equals r, it will become 2 times 3, 6. So if it gives you that and it doesn't give you the radius, all you have to do is divide this by 2 and you get the radius. Solve for pi r squared. I want to thank you for watching this video on how to solve radius, diameter, circumference, and pi, and how they basically all link up and solve circumference and of course area. But that'll be for another lesson. Thank you so much for watching. Yeah, thank you.